Good day viewers, welcome to this class. Please, if you are new to this channel, please subscribe. Before we begin to write on the board, let's try to understand the concept of place value. Now look on the board, place value. Okay, so we can see that as the name implies, it is the value assigned to the place of a digit. The value assigned to the place of a digit. Let's write the first 10 digits we have. We have 0, we have 1, we have 2, we have 3, 4, 5, 6, 7, 8, 9. Okay, these are what the first the 10 digits we have. The 10 digits we have. Okay, now let's quickly recall that digits are just values, are values that we use for what to represent number. For instance, we have two-digit number. It can be 32. Okay, it can be 41. Okay, note the numbers, the values are changing. Okay, but it still remain what, two or digits. Now you have three-digit number like this, 451. Okay, we can still have three digit number as 783. Okay, these are what, two-digit number, three-digit number. So digits here just represent the values of what, the numbers we see. Okay, now that is it for what, place value, the value assigned to the place of a digit in a number. Okay, now let's proceed with what we have. Okay, now we have from the 10 digits, we have 9 here. We have 9. Let's pick it up. We have 9. We have 9. Okay, now the value assigned to this 9, let's see it, is ones. The value assigned to this 9. Then you have 8 from the 10 digit number, for 10 digits. We have 8 here. Okay, and the value assigned to this 8 is different from the value assigned to 9 because of its position. Now let's see the value assigned to this 8 here. The value assigned to the 8 is tens. Okay, after 8 from the 10 digit we have 7. We have 7. Okay, so what is the value assigned to the position of this 7? Let's say it. The value assigned to the position of the 7 is 100. 100. Okay, 100. Sorry, 100. Okay, you have 6. What's the value assigned to the position of 6? Let's see it. It becomes what? 1000. 1000. That is the value assigned to the position of this 6 in this number. Now let's continue. You have 5. Sorry, 5. So what is the position assigned to this 5? The value, sorry, we have here, we have tens of thousands. You can just put here. Now we have 4. What is the position assigned? What is the value assigned to the position of this 4? Let's see it. It is what? 100. Hundreds of what? Of thousand. You can just put what there. Okay. We have 3. What is the position assigned to this 3 here? You can see it here. It is what? Million. It is million. Okay, let's just look into something now. We see that the value assigned to the position of this 9 is different from the value assigned to the position of this 8, is different from the value assigned to the position of this 7 here. Okay, even though we might see that the value here, the value represents 9, but the position of 8 is more greater than, far greater than this 9 here. Okay, you can see that the position of this 7, even though 7, the value of 7 is greater than that of 5, but because of its position here, its value is what, the value of this 5 is far greater than the what, the this 7 here, because of what, its position. Let's proceed. We have 2 here. We have 2. We have 2 here. Sorry, we have 2. Okay, let's see the value of the 2 has. Come over here. You have 10, sorry, tens of million, tens of million. Okay, then we have 1. 1. What's the value here? The value assigned to the position of this one. Let's see it here. Comes here. What is position? Hundreds of million. Hundreds of million. Okay. Then you have 0. 0 is among them. You have 0. Okay. What is this? The value assigned to the position of the 0 here. Let's see the value here. This 0 here carries what? The position of what? Billion. Its value is what? Billion. 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 Okay. But yes, we have exhausted the first 10 digits we have. But remember, digits are just values that represent numbers. We can pick any of this number and still it is still a digit. Okay, let's take 9. We can take 4, we can take 5, take 6, or just take 9. I have 9. Okay, so what is the position of this 9? Not this one here, but this one here now. Just see it, it becomes, the position here becomes tens of billion, tens of billion, tens of billion. Okay, now we have, let's pick another number there. Okay, you can just pick 8. Okay, now what is the position, what is the value assigned to the position of this 8 here? I have it here. Okay, don't mind my drawing. Okay, let's make this a bit better now. Now so we now have hundreds of billion. Okay, let's clean this and let's just make it to trillion and we stop. If you can just choose 2 or 4 or 5, or let's continue. I have 7. 7. Okay, what is the value assigned to this 7 here? Okay, let's clean it very well. The value assigned to this 7 is, let's see it, trillion. Trillion. Okay, trillion. Now we can see that the value assigned to this 9 here, even though the value is greater than the value of the 8 here, represent the value that this the digit here is greater than digit here. Okay, okay, the value this digit carries. Okay, but because of its place, okay, 9 is greater than 8. Of course we know that, but the position of 8 is now greater than the position of 9. So 9 is at the position of ones. Now, what are ones? These are numbers starting from 0 to 9. It doesn't exceed 9. Okay, you can say that the highest number to see in ones are what? 9. It doesn't exceed what? 9. Just can be 1, 2, 3, 4, 5, 6, 7, 8, 9 stuff. You can't go to what 10. You can't come over here and say I want to write 10 here. It's not acceptable. Okay, now the position of 8, you can see that this, we can call this tens of ones, tens of ones, tens of ones, tens of ones. It can only start from 10, though the least 2 digits is what? 10, just 10 like this. 10. Okay, it cannot be below this. The least 2 digits is what? 10. Okay, now we have tens here. It can be 20, it can be 30, 40, 50, 60, 70, 80, 90, 99. It cannot exceed 99 to 100. Okay, so you can just have more, you can have 24, as many as you want, provided it was 2 what digit. Okay, now we have what? 3 here, we have 7 here. Sorry, the 7 is in the position of what? 100. Position of what? 100. That is to say, this is what? The value, this position possesses or carries what? 100. Okay? Not 10, not ones, but what? Hundreds. Hundreds. Okay? Now, let's proceed. We have what? 6 here. What is the value of this 6 here? The value of the position of this 6. The value of this of the position of the 6 is what? 1000. 1000. 1000. Okay, now look at 5 here. You see, so we continue to do it and do it and do it and see that each digit here possesses or carries it what? Value based on its position. Each digit carries its own different value according to its position. That's why even though 1, 9, as we know, 9 is greater than 1, okay, but because of the position of this 9, this one here, sorry, we can see that 9, the value this position possesses is far greater than the value of this position here, even though it is 9. Now, with this in mind, we're going to look into something else now, but it's also very important. Remember, this place value doesn't stop at helping us to identify the value of the position of a digit, but it also helps us to what? Know or to read numbers. Now, let's do something like this. Remember, the hundreds of ones stops here. Okay, the hundreds of ones stops here. So we're going to group them what into what? 3 digits. 1, 2, 3, comma 1, 2, 3, 1, 2, 3. That's correct now. That's correct. Okay, so we can see that if you want to read this number, which will also help you to find the place value of each digit, it will be very, very simple. Okay, now we have ones here. So what are the numbers you expect to be here? You just have from 9 down, or from 1 to from 0 to 9. Okay, the number you expect here. You cannot see what 2-digit number here. Okay, here you only see from what? From 10 to 99. You cannot see 100 here. Okay, that is the value of its position. Now we have what? 7. 7 is what? In the position of what? 100. So you can only see what? 100 like this. Okay, 100 like this. I mean 2 digits. For instance, that is why these three, they are called what? They are what? This 10 here, this 8 here is what? Tens of what? Ones. The 100 here is what? Hundreds of what? Ones. Let's look at it. Let's prove it here. You have 100 multiplied by 9. Okay, you still have what? 900. You not have a 9,000. Okay, it is still what? 3 digits. Now you have 8 times 2. Let's say 8 multiplied by 2. You still have what? 16. It doesn't what? Exceed what? 200. They are what? Tens of what? 1. Okay, whatever value you're going to have here, it must be what? 2 digits. Whatever value you're going to have here, it must what? Digits. Okay, once you what? You multiply it with what? The ones here. So at this point, let's look into the place value of each digit and how we can use it to solve other problems. Assuming, okay, let's read this number first. Okay, so this number, this is 1. For the question is what? Ones, on tens, hundreds, thousands. Now in thousands or in thousand, it only stops at 9. Okay, now you have ones of thousands, ones of thousand, ones of thousand. So you cannot have 10,000 here. No, it's not possible. You only have 9,000, 8,000, 7,000, 9,000, or 4,000. You cannot have 20,000 here. But when you move to the tens of thousand, tens of thousand, remember tens of ones, okay? Tens of thousand now, you now have, you can have 20,000, 30,000, 40,000, 50. You can even have 99,000, but you will not have 100,000. Okay, now let's move to the next digit, which is what? 4 here. The 4 represents hundreds of what? Thousand. Hundreds of thousand. So one can say 200,000, 600,000, 700,000. Okay, but it will not exceed what? 100. Hundreds of thousands. Hundreds of thousands. Okay, the same is applicable here. You have three, you have 3, 2, 1. Okay, now the position of this 3 here is million. The value here, the value of each position is million. You only just have what? 1 million, 2 million, 3 million, 4 million, 5, 6, 7, 9, 8, 9, and it stops there. But when it comes to tens of millions, you have 20, 30, 40, 50 to 99. You cannot have hundreds of millions here. Okay, the digit must what? Be 2. Now the same is applicable here. You have what? 1. You have what? Hundreds of what? Millions. Million. Okay, let's go to billion. This is just what? The ones of billion. Just 1 million, 1 billion, sorry, 2 billion, 3 billion, 4, 5, 6, 7, 8, 9. It stops there. You cannot have 10 billion at this what value. It is what? Once what? Value. Okay, once. Now the same is applicable here. Tens of what? Billion. So it continues that way. So let's quickly read this number and be able to identify the what? The place value of each of them, and then proceed with what? Other task ahead. Okay, now remember we grouped all these digits into what? Three. Okay, three. I told you, I remember I told you earlier that this is the ones what? Position, hundredth position. Okay, so we can even say this is just 9. One. Okay, this is just what? 9. But when we have something here, it is assumed that we have 10. Okay, tens means what? The least tens is what? One 10 like this. Okay, it means okay, when you multiply this 10 by 8, okay, sorry, you have 10 like this, and you multiply by this value you have here, you have what? 80. Okay, equals to what? 80. Okay, now you see that the value here becomes what? 89. 89. Okay, let's proceed to read this number. Now we have what? 7 here. Okay, what is the value of this position, of the position of this number? You have what? 100. Okay, now you can just say 100 multiplied by 7. Okay, you have what? 700. 700. Okay, and that is to start with. You have what? 789. 789. Okay, so let's proceed. Now let's try to read this number here. You have 6,000. 6,789. Okay, you know, in the ones of thousand, you are not expected to see 10, 20, 30 or so. You just have to see what? Ones. I mean from 0 to 9 digit. I mean just one digit. Okay, and the ones, you see what? One digit. At the tens, you see what? Two digits. At the hundred, you see what? Two digits. Okay, so we can say that this is what? 6,789. Okay, now you come to the tens of thousand. Tens of what? Thousand. Let's say tens, you know, tens of thousand. Okay, when you multiply this with, you have 50 here, 100, then multiply by what? 5. You have what? 50. Okay, now equals to 50. So to read this, we can say we have 56 56,000. Okay, 56 what? Thousand. Okay, 789. 56,789. Okay, now we have another digit here, which is what? Hundreds of what? Thousands. Okay, let's, if you multiply this 100 by 4, you have what? 400. Okay, 400. Now I say 456,400 456,789. Okay, let's proceed towards millions. Okay, the million. These are the ones of million, ones of million, ones of million. So maybe you can have another digit here or number here. You can have five or so. It's still what you can have as many as you want. So in as much it doesn't what exceed 9. Okay, you have 3 here. So the value of the position of this 3 is what million. You have what 3,456,789. Okay, now we have to proceed. We have what million. Okay, you have what tens of million, tens of million, tens of million. Okay, remember the list you can see here just what 10. Okay, multiply it by 2, you have what 20. So you cannot say it is what 23 million. Remember that it's comma here, please, to separate them. You can just say we have what 23 million 456,789. Okay, let's proceed. We have 1 here, which its position is what in the what hundreds of what millions. You can say 100. Okay, when you multiply it has by 1, you say about 100. You can say 123 million 450 789. Okay, now we have what 0. Okay, the position of this 0, it doesn't matter the value here. Okay, but its position remains what billion. Its position remains what billion. So the position uh, of this digit here is billion. So let's proceed to the next one. We have what 9 here, 9. Now, what is the position of this 9? Tens of what? Billion. Okay. Remember, when you say 10 multiplied by 9, you have what? 90. Okay. So one can say 90 billion, 123,456,789. Okay. Now, let's proceed to the hundreds of what? Billions. Now, look at it here. We have 8 here, which is what? Hundreds of billion. Okay, we have 800. When you say 100 multiplied by 8, you have what 800. That's 890 million, 890 million 123 million, sorry, 890 billion 123 million 456,789. Okay, now the last digit here we have what trillion. Okay, we have what the trillion here is what on the what ones position of what trillion ones. You just have, it can be 9, it can be 2, it can be anything. You just have what 7 trillion 890 billion 123 million 456,008 sorry 789. So with this in mind, let's proceed to the what place value. We're going to do perform 2 tasks here or 2 examples, and we call it a day. Now, assuming we have a number like this, okay, so from here we can see that if you ask to find what is the place value of 6 here, okay, first of all, for you to, if the number or the digits are not grouped, try and group them into what 3 after counting what first what 2 digits, 1 2 3, but you group them 1 2 3, you group them. Okay, you group them. Okay, now we ask to find the what is the place value of this what 6 here. Now very simple, you have what ones here, you have tens here, you have hundreds there here, you have thousand here, ones of thousands. Okay, tens of thousands. So the position of this is what tens of what thousand. Okay, So if you're asked to find the position of, we have 3, 7, something like this, uh, 0 like this. Okay, if you have to find what is the place value of this 7 here, simple. First group the numbers, the digit into 3 if it's not done so. So let's group it, separate it with comma. Okay, now you have 1. Okay, this is 1's position. You have 10's position. Simply what? 10. You have what? 7. Okay, which is what? 700. Okay, so we can see, and you have what? 3,710. Okay, so we can simply say that the position or the place value of this what? 7 is what? 700. 700 or 100. Okay, is what? 100. Okay, so I hope you enjoyed the class. Please do subscribe for videos like this. See you next class.